Got a 2013 Acura TL. What's going on with this is a simple alternator. It's funny because I'm doing a warranty replacement on an alternator here for this Lexus. Things happen. Hopefully we don't have the same issue in the future. But the alternator light is on. It's working fine now. The charging system works. What was going on? The lady parked the car, went into an establishment. Before she did that, everything started going haywire. The battery indicator light came on. So this does have like a little message center for the battery. We'll look at that. I'm just going to go through some basic tests. I don't want to make this overly complicated. I just need to see why it's charging simultaneously generating a malfunction with the charging system. Now this does have a pretty intricate system. I did check the L terminal. Let me see if I can look into this. I did check the L terminal, which is this blue and white wire here. You see my witness mark here where I had pierced that blue and white wire. And I checked for ground while it was running, because naturally when an alternator fails, you get an indicator. On the regular traditional internalized regulating systems, you'll have the alternator will ground that wire out, and because it's an isopotential system with the old systems, you have a diode or a resistor going to a light, and then this supplies 12 volts when it's active to basically cancel out the voltage, and it doesn't short out that bulb, and you don't have the bulb illuminating. This, on the other hand, it still works off the same principles, but it's more of a digital, like electronic. The gauge pretty much sees, oh, okay, it's grounded, let me activate this light. But the thing is, the charger system is putting out 13 volts, and there's a fault with the charging system. So I'm gonna tell you what I did. I did check that L terminal. I used my test light and put it on 12 volts, and it was grounded out. I'm going to show you that. And then we had an indicator still on in there. I mean, it was able to short out a test light, so it was a good legitimate ground. So I did that, and I just want to make sure that the alternator is defective, because there's a couple other things that can fail on this vehicle that will cause a charging system malfunction. Besides that, I mean, it also could have some faults regulating in some fashion. For I understand, there was some battery sensing battery sensing components on here that could fail. I think this is the temperature sensor for the battery, and to monitor the voltage and stuff. I'm not sure if that's the amp clamp typically would be on a negative. I'm not sure if it's integrated with this or not, but usually it'll wrap around in some fashion. So I don't know. I'm gonna be honest, but I know for a fact this is that also regulates the temperature and stuff for that battery. So I'm gonna show you what I'm doing with this in regards to the light. It was only 2 tests I'm gonna do. Check the L terminal, and I'm gonna pair it with the new one, and then we're gonna check that light, because the light's off now, and per the directions in the service information, you should be able to remove the connector, and the battery light should go out when you turn the key into the on position or push the start button in key on, engine off position. So all the lights will basically be on. So let me show you what I did with the L terminal, that blue and white wire, and then we'll compare with the new one to see if it's like a legitimate test, because I didn't see this in the service information. The service information in regards to testing the alternator did state you can remove this green. That green and white wire is what grounds out the alternator, if I understand, and charge it up. And it said you can remove that to see if it goes into a fully state. I think it grounds to deactivate, if I recall properly. Don't hold me on that. I had to look back at the service information. If I find it, I'll put it in here. But 2 things. Let's get linked up to that white and blue wire. Start the car up and see that the test light's active. If that's ground, we're going to show out the test light with that being on positive, which indicates that there's a fault with the regulator. and the alternator, and then we'll see the battery lights on in the vehicle, and one other confirmation that there was a fault with the alternator versus some other superficial component external of the alternator is to disconnect it and see if the battery light goes off. So we'll do those two things, and we'll compare it afterwards. I'm gonna try to make this as quick as possible. Try to. Pierced in there. It's back. I think this one up to start. I got everything connected. Piercing pin on white and blue. That's our L terminal. And again, we're checking for. It should be 12 volts on there. So when it starts, now I'm going to get some numbers for you because it's at an off state. So key on engine off. We'll have a value, and we're going to compare that value with the new one and see if anything changes. So currently, no pun intended, currently, we got a ground signal because we're linked up at 12 here, so we're looking for ground. So it's currently grounded out. Theoretically, I should be able to touch my test light on here and illuminate. So we do have 12 volts. What I'm gonna do, I'm gonna start it up. I'm gonna show you that the battery light's on, and then we'll check the charging system. Our test light is still illuminated. We do have higher voltage value coming out, so the car is outputting more. So if we look at the value here, the car is producing 13 volts, almost 14 volts. But our battery light is still on. So our indicator, charge indicator, should also be on. And it is. Let's see what the message says. Check charging system. So I think there's an L terminal problem with this, even though the alternator is working, but I think there's also intermittent fault with this. So I think I've had this happen where the L terminal just fell inside the alternator despite the alternator still charging. So I'd imagine since the F terminal controls the charging capacity, that's probably what's still working. But I guess, correct me if I'm wrong, but I'd imagine the alternators can fail in so many different ways. But on this, the L terminal might not be as integral because it's just utilized as an indicator. I'm assuming. So let's do this. So we know that our L terminal has failed. So what we're going to do, this test should indicate, once I disconnect the connector, that the wiring integrity from the alternator to the PCM is proper. Because like I was saying, it's the ISO potential. So there's 12 volts on the old system. I'm thinking about how the old system worked. I don't think they pretty much changed anything. Because the old system, let me cut the car off. So with the old system, if you have like the basic circuit with 12 volts, and then this, if there's an internal fault, it would ground this out. And once it grounded out, that's what would short that lamp, that bulb, and that indicator inside the car. So I don't think that same system changed. Let's see here. All right, so yeah. So now, being that the alternator isn't sending that ground signal to the L terminal, there's no indicator here. Let me show you. This should work theoretically. So if this is our L this is our L terminal. I should be able to take this, ground this, and that should be able to generate a light. I'm not, yep, it does. Look at that. Okay. So what I was trying to do before when diagnosing the L terminal, and then I knew it wasn't gonna work. While it was running, I was putting that on a 12 volt source because that ground definitely supersedes that bias 12 volts there, going through that test light, and I wasn't going to send direct 12 volts through that circuit by shorting some stuff out. Test light is always the safest way of testing the circuit 98% of the time, because you can screw some stuff up. All right, we did our basic test. We know the alternator's fucked, and right now, when I'm gonna get this, my new alternator came from O'Reilly's. Well, I got 2 alternators, so I'm gonna get this back on here, let this cool down, and start getting some stuff pulled out. I'm probably not gonna, well, yeah, you know me. I'm probably gonna go through my repairs of pulling this out. Just probably go some basic stuff, as you can see it. But other than that, my biggest thing is just doing these 2 basic tests. So we did the service information test by pulling the connector, and I tried my own, which as far as that test light go. So you can, if you don't have any scan tools or anything, and you want to test that L terminal, just go to that white and blue wire, take a test light, and just ground it. Does it illuminate? That's basically your L terminal inside the conventional vehicle. But this is the vehicle isn't conventional, so. All right. I know for those watching, if they notice something's off with this, so whoever put the coils in there, I understand how they numbered it, but this is improper. This is not Honda's numerical order. So bank 1 is typically in the back, 135 and 246. So I thought it was pretty interesting. But I understood what he did, so I'm not going to joke, clown about it. It looks like I need to take the tensioner off to get to that last bolt at the bottom of the alternator. Let's see if you can see it down there. But I got it cleared. Focus right down there. So I wonder if I got it cleared by using this contraption. It didn't take but like 2 minutes to engineer this. So I got 2 bungee straps holding this so I can get this bolt loose for the bottom of the alternator right here. I don't want to take that tensioner out, so I'm gonna try to rush and do that. I got 2 bungee straps. I'm gonna put some safety glasses on and just in case it comes off. It's a 14 millimeter, and I just got a longer wrench, obviously. Old leverage trick. All right, let me get this off. Try this. This is a reducer, but it fits perfect. Okay, I had a 14 millimeter 3/8 to 1/4 inch reducer. I got plenty of room and it worked great. So I gotta update that 14 3/8 because that thing is just horrible. Can I get that's what's holding it in there. Got it out. See if it'll snap out. Nope. All right, I'm gonna get everything back in there. I'm gonna run that lower bolt through the bottom first to make it easier, and put everything back in reverse order. So the part I didn't show obviously was getting the fan out. I did have to take the splash guard down. That's undercarriage. That's at the undercarriage. I just used this device here to remove the fasteners. Gain a little access, and it was a 10 millimeter to get the lower bolts for the fan down there. And once I got those out, pull the top bolts for the fan out, which are easily accessible. Pull the connector off from the fan, and then there's two plastic connectors at the fan shroud on the housing of the fan. You have to pull off, and those are, you'll see them. Might have to take something that's kind of break, because I don't know how you're going to get between the fan and loosen those up without damaging the fins, and you don't want that to happen. All right, I made the alternator go in a little easier. This compression fitting here. So as you tighten the bolt up, it pushes this compression fitting towards the housing of the alternator to keep it clamped down and tight. So it hit it with some brake cleaner and then penetrating oil. You can go on the side here. Let's give it some taps. And it'll back up a little bit so you have plenty of room and it'll go in smoothly. All right, got a new alternator back in. It was no time to throw it back in there once I had that tensioner pulled back. So it was very easy. And then I had that compression fitting knocked out a little bit. Everything went in perfect. I just gotta get the fan in there, which ain't gonna take 3 minutes. But we're gonna do the same basic test before I get everything buttoned back up. We already know if I cut the key on with the connector unplug, the light should go out. So I'm not gonna do that test anymore. I just wanna see if that L terminal now isn't grounded out. So we're gonna go back, right back on battery positive with the test light, because we're still connected to the L terminal. And I'm gonna start the car up and see what happens. Theoretically, it shouldn't light up. It should say stay unlit. I'm gonna connect the battery back. Let's see what happens. So the battery light is out, so theoretically, the test light should not be illuminated, and it isn't. We're gonna go to ground. Okay, so the system don't utilize 12 volts, but so it's like I said, it was a low voltage signal. I didn't know. Yeah, this belt sound horrible, but I got a new one on its way. So it's like since I did with O'Reilly's, the Gates brand is coming, so we'll get that taken care of. It just sound bad. I knew I should have replaced it because I saw some little frets on the side. It looked fine, but it just like it got oil on it. And I don't know if my hands did it, but it's worn and it should be replaced. It's cool. She's fine with it. Getting a new one on there, we'll be fine with that. So learn something new. It doesn't supply a 12 volt source. It supplies a 5 volt. So that's something new. So if you wasn't test this alternator, test the L terminal, you should get like a 5 volt reference. So that you would put in that will be battery positive, and then you would put your probe on negative here, and you should see 5 volts, 5 volt source. So we'll learn something new with that. This is supposed to be like I'm gonna look up the labor time again. It's close to a 2-hour job from start to finish to replace this alternator. I know I got this done within an hour, and putting it back was a cinch. It was no problem, especially just doing this number here and not having to take that tensioner off. It made life so much easier. I don't think I have anything to say, but we did go through some basic tests with the L terminal. I'm gonna put some wiring diagrams up and give you the labor time, but this is pretty much cut and dry. I use a 10 millimeter 12. That was a 10, 12, I want to say, and a 14 millimeter, if I recall properly. Don't hold me on at 12. I want to say I used a 12, but I had it on the Lexus. I can't remember if I used it on this or not, but I think I did not actually. But I want to say 10 and a 14 millimeter in various sizes. So that's what I used to get this off to this point, complete removal and installation. But if anything happened, I'll definitely update. Hopefully I don't have the same issue with the other vehicles and have to do quite a bit of warranty replacements. Oh shit, it did twitch a little bit. I think I'll be fine. It's just settling. I think I'll be okay. Hopefully I don't have any alternator issues with this. I've been having a lot of failures come back. I'm not sure what the hell these part stores are doing. And the way I look at it, this is just the byproduct of having to pay lesser prices than you would at dealership. But at the same time, you talk to a person that works at the dealership, they're going to tell you things fail too. I don't think we can win either way. The best thing I can do is just swallow my pride and replace the part as it comes back in, do the best I can during the assessment and installation. The rest is on the part company, the part distributor. You get AutoZone stuff, they're going to fail. You get Advanced Auto stuff, they're going to fail. Napa, United Import, wherever it is around here, it's going to fail. You go to the dealer, their stuff's going to fail. So, and a lot of times, like with the Lexus I just did, it's not even worth filing a labor claim because, you know, by the time you go through it, they're only going to pay you half your labor. If you charge $100 an hour, they're going to pay you $50 an hour, and then they're going to charge you. You know, I don't think you're going to get the full hourly, the time. If I recall properly, don't hold me to it. I just haven't filed a labor claim in so long, and it's usually not worth going through the effort of replacing it, writing the labor claim up as far as they need a receipt from the initial transaction, and then they need a receipt as if you were doing the a job for the first time again, for, you know, supplying that information for the warranty claim. So it's like, it's not worth it. And this is like an 8-hour job. I can understand it, you know, taking some time out to get your money back, but you're not gonna get what you lost. And assuming that if you've done everything like you're supposed to, but we're not dealers, we can't get, you know, dealer prices and stuff. It would be great. I will be like a millionaire right now, honestly, if I could just charge what the dealer charge, but we can't do that. And so either way, but it's not worth filing labor claim. Like I say, hopefully this alternator work. And you know, one thing I might do is just once I finish the year out, see what my total, compare the total cost of parts, like the gross, and then just, I guess, compare with like a net with returns and warranties. Because I'd imagine a 5% failure rate, I mean, that's pretty significant. 5% failure is a lot. So if that's I mean, you can do 10 water pumps a year, and that's a lot. if you spend $30,000 or so that's $50 for every 1,000. So for every 1,000, then you got $10,000. That's $500. So 30. That's like $1,500 worth of returns right there. That's ridiculous. That's just too much to having some issues with. And I expect maybe a 1% failure rate. I'm hoping, because I do spend quite a bit at O'Reilly's, and I don't like for things to fail. It hurts my feelings when things fail because it kills my ability to be productive. But anyway, I feel like I'm ranting. But you need to work. Just work like you're supposed to, please. And don't break, please, for the sake of my sanity. But anyway, hit that link, subscribe to the channel, stay informed how to research my work. I'll see you on the next one.